Hello everyone and welcome back to Clinical Cousins YouTube channel, where today we're going to discuss how the SA node and the AV node work. So this is a very important concept, and if you know just a little bit about the nodes, then suddenly everything you know about the heart makes a ton more sense. So for your convenience and my convenience, I've drawn an SA and an AV nodal cell, and we're going to see what an action potential looks like in these cells. So from our previous videos, the heart is stimulated electrically and spontaneously or without external influence, which leads to a mechanical or physical contraction of the heart. So if you want to put it in really simple terms that even a 5-year-old can understand, it's the heart's light switch is turned on and then it squeezes. So who's the most important player in the electrical game? Well, it's the SA node. It's the SA node. So it sits in the posterior wall of our right atrium, and it's famously known as the pacemaker of the heart. But what if I told you that the heart has a lot of pacemaker cells? Well, what makes this one the king? Why does this one get to lead the heart? Well, the SA nodal cells are sort of funny. Well, no, really, they have a lot of ion channels, which are called funny sodium channels. Now, these funny sodium channels actually allow a slow trickle of sodium into the cell. In fact, the AV node and other pacemaker cells also have funny sodium channels, but the difference is that the SA node is the funniest. It has the most funny sodium ion channels. Now, we also remember that sodium is a cation, it's positive, and it also wants to enter the cell via the actions of the sodium-potassium ATPase. So when we open up these sodium funny channels, sodium comes rushing in the cell, our cell becomes more positive. So let's take a look at what happens, or in other words, let's take a look at how electric the SA node gets. So with the time being on the bottom of our graph and the millivoltage on the side, you can see this is negative all the way up to positive. We can see that unlike most cells, the SA node doesn't have a resting membrane potential. It can't sit still. You can think that the SA node kind of has ADHD a little bit. It can't sit still. Well, these funny sodium channels leak into the SA nodal cell and make it more and more positive. This is called phase 4 depolarization. Now, the SA node has the most funny sodium channels, so it naturally reaches threshold by this dotted line the fastest, which means that it spontaneously fires action potentials the fastest. Spontaneous meaning by itself, of its own willpower. Now, this is why the SA node is the boss of the heart rate. It is because it has the most sodium funny channels and it has the fastest rate of phase 4 depolarization. This is called overdrive suppression, meaning when the SA node is the boss of the heart. This is because the SA node is the fastest firing pacemaker cell, so it suppresses all of the other wannabe pacemaker cells. Note that the SA node suppresses all of the latent wannabe pacemaker cells in the AV node, the bundles, the Purkinje cells. Okay, so we hit threshold, but what's next? Well, understand that the SA and AV node work in similar ways regarding their action potentials, meaning that these are going to look the same. The only difference is the SA node is just a little bit faster. So once we reach threshold at this point here, the SA and AV node open up their calcium channels. Notice how I've kind of drawn it clockwork so we can see the timeline. So they open up their calcium channels, and all of a sudden they have this rapid influx of calcium ions into the cell. This is called phase 0 depolarization, or upstroke. So we know that our cells have become depolarized. They're full of calcium. Now what happens next is that the depolarization sort of wakes up our potassium channels. Now we know that potassium always wants to leave the cell. So when these potassium channels are open, the positive potassium floods out of our cells, and we call this phase 3 repolarization. And this is the exact mechanism that returns our SA node and AV node back to its original state. Yes, you guessed it. These sodium funny channels are not going to waste any time. They're going to allow sodium to leak in, and we can see that the process starts all over again. So why is the SA node the pacemaker of the heart? If you got that question on an exam, well, it's because its massive amount of funny sodium channels allow for sodium influx, which brings it to threshold faster than all of the other pacemaker cells in the heart. This is actually what gives us a heart rate of around 60 to 100 beats per minute for adults. And what ions are involved in the action potentials of the SA and AV node? Well, we know that sodium is involved in the spontaneous phase 4 depolarization. We know that calcium is involved in phase 0 upstroke, and we know that potassium is involved in phase 3 repolarization. As always, thank you for taking the time to learn with us today, and I hope that you like and subscribe for more content. Thank you.